Hello YouTube, so today I'm going to be making a video on setting up a structure for your API in Golang. So looking at the diagram in front of me, we've got the main entry point. Obviously this exists within CMD, and we've got a server with routes and handlers. So this is where it pulls in all of your config, all of the routes and all of the handlers. Obviously these come from somewhere, so we've got an event folder structure, and of course this can be called whatever you want. It's more of a feature folder. So looking at event, we have a delivery section. This is your presentation, so you can have HTTP, gRPC, GraphQL. Obviously we're going to focus on HTTP. And then a use case folder where you're going to have all of your use cases. And lastly, a repository folder, which we won't get into in this video, but you can set up all of your connections to your external databases, hence the infrastructure. And of course, event does have access to a models folder, which will be your domain logic, and this will hold our event. Okay, so I'm just in a empty folder, as you can see, and first thing I'm going to do is make up the folders necessary. So the first folder will be CMD, and we'll also have internal, and inside CMD we'll have API, and inside internal we'll have event, and alongside event we'll have models and server. Okay, so our route will exist here, so I will create the main.go. Of course this will throw an error because we do need to go mod init. Obviously you can call this whatever you want, and once that is done the error should go away. So we are going to be using echo for this tutorial, and if I do echo here, you're going to be able to see the module you can import. And of course I've already got it, but that's what you will do with any package you want to include in your project. So here we've created a new echo instance, and the first thing you can do is obviously start this with a port. This is very basic, and we'll extend this in a moment. So here I am adding a string as the address. And we're obviously gonna log if this fails. And the way you run your application will be go, run, and then obviously from root we'll need CMD API. And there you have it, the default echo start right here. We haven't really configured it at all, but it is up and running. So we now want to head over to the server folder, and we're going to make a routes.go and a handlers.go. Okay guys, just pretty quick, I did make a mistake. It's not routes.go, instead it is server.go. So of course we will need a server struct, and this will carry around a lot of our configuration. So that will include a address and also our echo server. And this server is going to have a new a factory function. So the way you do that is new server, and we obviously want a address, and we also want an echo. Actually, we don't want an echo because we're going to generate it during the process, so we're going to return a server here. There we go, and obviously we're going to put in that address. And then the echo, we're just going to create a new one just as we did before. And then, of course, from server, we're going to have a run function. So once we've given them the server, they can run this server. And this will have an error, just like the start does on Echo. Okay, so first thing, we do want a local server. And that's because we need a HTTP server. And to explain the difference, this server would hold like your logger, your config to set up the internal server to then start the internal server. And you'll see that in play here. So for example, we're going to pass it the address from our server instance. And of course you can pass like all sorts like handlers, whatever, but in our case we're not going to configure this too much. Then of course you can run a gofunc, which is a go routine, and this basically runs it on a separate thread. And all we're going to do really is if equals s.echo.start server, and then we're going to pass in that server, and then we're going to say if the error is not nil, we're going to, for now, just log.fail, start the server. Pass that error in there. So that basically essentially runs the server. The next bit I have done a bit of research on, and I'm going to try and explain it as much as possible, but it is going to include a channel. So we're first going to make a channel here. So the way you make a channel is make and then chan, and then we're going to pass in OS signals. And I'm not entirely sure what the 1 means, but it's a size, so I'm assuming we can only pass 1 in. So we can only pass 1 signal in, and this is going to basically hold our cancel signals. And we're going to do signal.notify, and we're going to notify the quit channel when a syscall.sigint, and just before here OS interrupt. So that's when you hit like your Command C on Mac and your Control C on Windows. It will basically notify this channel, so it will send in here the 1 interrupt signal to the channel. And to obviously, so if I don't do the next bit, the function is going to run, the server is going to start, but the function will end, and the server will not even get started, and the signals won't even be listened to. So to basically block it, we can do this, and that essentially blocks the it essentially blocks the function until a cancel signal has been hit. So we're also going to do a shutdown here. So we're going to make a context with timeout. So this allows like grace period. So not as soon as this gets called, because if we cancel, we might have ongoing tasks. So here I'm going to do a context background, which is just a default context. It's a plain context, and we're going to give the server 5 seconds to do what it needs to do. And then of course when the 5 seconds is up, shutdown's going to call, and here we're just going to return s.echo.shutdown with the context. So there we have it. So Echo does have a built-in shutdown method which stops the server gracefully with, of course, the context we've written here. And obviously to connect all of this up, we're going to have to remove this code here, and we're going to need a server. So I'm just going to call it S, and we have the server package there, new server, and we need to pass in our port, which we can do whatever we want. I'm going to do, let's do 4000 for now. There we go. So just remove these. And we can do if equals s.run. Obviously, we've not really done much but wrap it, so it will return an error if it fails running. And here we're just going to do a log.fatal server could not be ran. And if we go over here and run, you should notice not really much has changed. Yeah, there we go. So it is running, and when I do hit this, however, so if I do Control C, the signal did get hit. We didn't log. We could log actually, that would be good. And it will instantly shut down if there isn't any task to be done. So if we go to server, so obviously when a signal's been hit, we can just do a log info. Actually, how do you do this here? Log.println server is stopping. Yeah, so now if I do that, server is stopping. You can see there. So obviously you can perform tasks when they've requested to stop the server. In this case, we're handling a shutdown process where if tasks are ongoing, they will be completed first as long as they're within the time frame, and then of course the server will shut down afterwards. Okay, so currently we have given them this server struct, and there is a few more things we want to really do. We want to be able to define groups. We want to be able to obviously define routes. So if we go to the handlers, this is where most of that logic will exist. Okay, so the next step would be to allow our app to sort of define its handlers. So we'll be able to define groups and define the routes against those handlers. So here from the server, we're going to want to map handlers. We also want to retrieve the echo instance. So we're going to call it either echo.echo, and we'll return an error if anything goes wrong. So here we can get straight into it. So echo group, And this is how you define a prefix for any of your routes. So the default prefix is going to be API v1, and we're going to call that v1. And then from v1, we can also declare a group. So I'm going to call this health, and we're going to call that health. And then to demonstrate, we can do a get, and we're going to do it from the root. And from here, I'm just going to generate a function which takes a context and returns an error. And from here, I can return c.json, and we're going to return status. Okay, it's not going to have any crazy logic in, it's just a demonstration at this point. Because right now we have a server, but we don't have any endpoints to test. So looking at this JSON method, it takes an interface. So this returns a struct, obviously the data that you want to send out, so the message, everything like that. So for now, we're just going to hard code a struct here. So we can do message string, and we'd call that message, and then status int, and we're going to call that status, and then here we're going to open this up and say message is healthy, and status is HP. Okay, there we go. And here I'm just going to return nil. So we should have a few groups, and obviously health will exist on API v1, and then appended will be the health. And we should get this response here. So yeah, I think this is pretty good. And then we'll go to server. So on server.go, just before you start the channel, because remember down here is going to be blocked. So here we're going to do an error. We can actually run this in an if error, and we're going to say s dot map handlers. We're going to pass in our echo instance, so s echo, and there we go. And if this happens, we're just going to log dot fatal error as occurred, mapping the handlers. So now if we go and run this, and if I do a curl, I want all of the information back. And if I do HP local host 4000 API v1 health, we're going to get that message we recorded back, and you've got healthy, you've got status 200. So everything is working correctly here. Now of course we do want our own sort of feature here in a group, so we're going to say event, or we'll call it events v1, because we want to extend that API v1, and then group and events. So now from events I can define these routes just like we've done here. So moving to events here, we're going to create a new folder called delivery, and then HTTP, and then in here we're going to say handlers.go, and this will be packaged HTTP, and we're also going to say routes.go. Okay, and firstly we're going to move into the handlers.go, and we're going to define a type called event handler struct. So right now it won't hold anything in there, but you will be able to basically anything that you need to pass down to these handlers, you can basically declare them as a dependency. So first we're going to do a get. So this will be via the event handler get. And before we do this, actually, we're going to have to basically define a way to collect this event handler, so a construct. So if we do new event handler, and obviously anything you want to pass in here, that's what you put there, and we're going to say event handler, and we're going to return and event handler. Okay, and here we're going to return a echo.handler func. So this will essentially return an endpoint. So this is obviously a C context error, a normal handler. And here we're going to return. So I just made a mistake. We did not need the pointer before echo handler func. So if I return func, it should now allow it to generate that context error. And you'll notice this is the same one that exists here. So we will be able to place it inside of a get request, etc. our route. So if I go back to the handlers, I will now be able to sort of simulate. I'm obviously not going to get one from the database. That'll be way too long of a video, but I'm going to simulate collecting a event and returning it in JSON. So firstly, we're going to need that event type. So back into here, we've got the models, and I'm just going to create event.go. And we're just going to create an event type, and we're just going to give it an ID of int64 and a title of string. Now obviously you will be able to extend this as well, give it some functions, etc. But for now we're just going to leave it like that. And we're going to go into the other handlers, there we go. And we're going to define a event based on what they give us here. And the way you can do that is via this context. So we can get a param via cparam, you see here. So we can get a name, or we can put in a name of the parameter we expect back, and then obviously that'll return it back to us. Obviously always in string format, hence why I chose int64, you'll see in a sec. So if we do ID, we'll do string convert, of course that needs to be imported, and we'll do parse int, which as you can see returns an int64 by default. So now we can do cparam ID is what we want, and 1064. There we go, and obviously you need an error. And we're just going to do this. So if the error is not nil, we're going to do a return c.json. And we're going to do a HTTP add request. And we're going to do a struct with a message string. You will have to do your JSON literals because they will not print otherwise. Status in JSON status. Here we're going to do message add request. And status add request. There we go. And moving on, we'll just simulate this for now, but we're just going to make an event here equals models. So it'll be an and models dot event. We're going to say ID is equal to, and we'll set it equal to that ID we got there. Title, example event. Okay, so once we've created the event, we now just need to return the event. So we can do that pretty easily with return c.json and our status of OK, and then just the event there. Obviously, eventually you'd use an envelope to wrap it nicely so data points to the event on the front end, but for now, this is fine. So to obviously get this working, we need to go back to the handlers, and we need to just do events.get, and then obviously from here, we're just going to do default, and then we're going to get our event handler, which we need here. We will need to import our own HTTP package, which I don't think it is found here. So I will have to manually type this out. And as you see, after typing that out, I have the new event handler. So now we have that event handler, and we can now call event handler.get. So very basic, we are going to improve this. And if I go here, stop the server, I'm going to run it again, and now instead of that, I should be able to call event. We have made a mistake here though, because we need the ID. So to do that, we'll need to just pass in this colon followed by the variable name. And now if I restart the server, because the changes would not have been made, can now call event1, and we've got a not found here, and that's my bad, I didn't put events. There we go, so we've got an example event. If I type 3, we get 3 back. Obviously there's nothing on the database, we're just simulating this, but that works perfectly. Now I don't know if you guys see the problem here, but this is going to get massive. We're going to have all of our events inside this map handlers. So we are going to make a function to help us out here. So if we go back to roots on the event folder, we're going to make a new function called map roots. And we're going to need an echo instance, obviously. And we'll need it to be a pointer. And here we're going to do e.get. We're basically going to do what we did before. And we're going to need a instance of our handler as well. Event handler. And we're going to need e.get. This does not need to be e, sorry. It needs to be h. And get. There we go. So very simple. We're now going to go back to the handlers on the server, and we can remove this one, and instead we can pass the handler down to our roots. So we're now going to say event http .map roots, and we're going to pass the s.echo and the event handler. And of course we also need the group. I did forget about that. So if we go here, we need the group, and this will be an echo dot group. So we actually don't need the echo here. So we're just going to come and remove this. And instead we can just attach the group. So if I go handlers, and instead of that, we're going to say events. And there we go, it should all run exactly the same. We've just put it in a separate location so we can stack everything to do with events inside of the events folder. And of course this can extend with whatever you like. So you had a news HTTP, that would also go there, etc, etc. So the next thing to do is interface, because we're throwing around a lot of pointers here to different objects. We should be able to replace a lot of stuff as well. When we get into use cases, we'll also need to declare a interface for that as well. So the way we're going to declare interfaces is on the root level of the folder. So here I'm going to say delivery.go, and we're going to say package event, and I'm going to say type, and we're going to say handler struct, and our handler currently has one method, and it's a get. And this obviously returns a echo dot handler without the hand. And it's not struct, sorry, it's an interface, of course. And we will need to import echo. And it is a handler func. There we go. So that is that. So now we're going to have to replace our instances of the handler, and that can be seen in roots, for example. So instead of this, we're actually going to get an event dot handler, and it will still work the same. And same with here, we're going to return an event dot handler. And you can see we still return that memory address, and we don't need to return that pointer because it will be a type of that. We don't have to specify what type now, so we can replace them pretty easily. And here we're gonna do event dot. Actually, we do need that, sorry, because that needs to be a reference to basically fulfill the interface. But yeah, that should all work fine. If we do go to main, it will be broken though. So if we go server handlers, okay, it's actually not broken. Let's have a look. Event handler, new event handler, yeah, all works perfectly fine. Should still work here. Let's give that a test, yeah. And that's a lot nicer having that interface declare what methods we have in the delivery. So moving on to the other area of this project, so we'll need use cases. And this basically separates the logic. Right now we have a lot of logic here, which we really shouldn't have. For example, if we go to, so not that one, if we go here, we've got a lot of logic here, where we're basically, we'd even be calling the database here, which is not what we want. So we want to split off, say, collecting the events. So imagine this was collecting event from repository. We don't want this inside our sort of presentation layer. We don't want any logic here, really. Obviously, we want to do the bad request if they have requested poorly, but we don't want any logic like this. So we're just going to separate this into a use case. So back here, we're going to make a use case folder. And this is going to have use case.go. And we're going to call this event UC. And for now, it will have nothing. And we're going to obviously make that new function. So new event use case. And I'm going to leave the return because we're actually going to jump ahead and real quickly declare that interface here. So we're going to say type event UC struct, not struct, I need to remember it's an interface, and here. And this is where you declare stuff like find by email, etc, etc. We're going to do find by ID like that, and this is obviously going to take a int64, so ID int64, and it's going to return a models dot event or an error. Classic template really for this sort of stuff. So, and obviously it will look pretty similar with of course the repository. So if we go back into use case, we can now return a event dot event UC, and we'll return an and event UC. Obviously this doesn't fulfill it because we need to make our function. So use for use case, event UC, and we're going to have find by ID. We're going to have a ID int64, and we're going to return a models.event or an error. And we'll return nil for now. And of course that error's gone away. So with the ID, obviously we won't have to pass any params or anything. That is the job for the presentation. We just expect logic to take place here, and that is it. So obviously we're not going to do anything crazy here. We're just going to return our model with our ID being the ID that passed us, and then title, return that, and we're just going to say example event. Obviously this is for simulation reasons, you would obviously put your logic here. I'm just going to say nil at the end. There we go. And then if we go back to the handler, we can now get rid of all of this, and we're going to need a reference, and this is where I'm sort of demonstrating how you can pass stuff to one another through dependencies, and we need that use case. So we're going to say event UC, and this is going to be an event UC. So here I can now do event UC, obviously part of our handler, dot find by ID, and we're just going to pass that ID in there, and we're going to assign that to the event, and we do need to check for an error as well. So if it's nil, and we can pretend it returned an error because it was not found. So we're just going to basically copy this here, so and then instead we're going to say not found dot not found. There we go. And here also not found. Now there is an import here I need to remove because we're no longer using that. And that should all work the same. We do need to declare obviously that dependency in the new, so we will need to go back to the server here, and we need to get that use case before the handler. So we're going to say event UC, and we're going to do the event. So it will be the use case we'll need. So use case dot new event use case, and here we haven't declared it, so we do need to go here and do UC, we'll say, and this needs to be an event dot event use case, and then here we need to input this, so event use case event, it's actually we've just called it UC. So now if we go back to the server, we'll be able to say event use case, and that'll pass down, so we'll be able to use that. This should work properly. exactly the same as we've done before. There we go. So we've now got use cases, so we can now define many things. Find by email if you're doing authentication, etc, etc. It's all grouped in its own little area, and all we need to define for each sort of, I'll call it a module, I guess. You could have an auth module, a news module, events module. You can just define your use case, handler, and then obviously call your routes function to obviously attach all. So that was all I wanted to cover here. We did not get into repository or anything like that. I haven't touched on that myself in this sort of structure, so I will be learning that further. I just wanted to basically teach you guys something I've learned in Golang, and of course I do want to get into logging. Right now we are doing very basic logs, so if I cancel the server, you see a little bit of structure, but I do want to either choose from the top login sort of libraries, so I might choose Zap and make a little tutorial on that, and I'm just going to build it up because obviously I'm building my project and I'm experimenting with stuff because my project is going to be production ready, so I do need to experiment with all this stuff and know it off by heart, and this is why I'm deciding to make a tutorial for it. So hopefully you guys learned something. If you do see something that is a bit odd, please comment in the comment section and I'll be sure to read that. So yeah, see you guys in the next video.